Right, so we're recording this discussion to ensure that at the end of the day, we have the video available so you can watch the video and take down notes. Our focus today is on how we analyze certain number patterns. For example, it is very important that you're in a position to understand and interpret the notion of functions and number sequences. Right, in 6.1, we're asking the question, write down the next term in the sequence. The sequence is 5, 8, 11, 14. And you can see, therefore, that here there is generally an increase. So there is actually a plus 3 that's actually being performed here. And then now you move here as well, there is a plus 3. And also here there is a plus 3. Okay, we can see therefore that 3 is being constantly added to the preceding term. The question then becomes, what do we do? What do we do? So in the end, therefore you add 3 here. So if you add 3, you have 14. Right, if you have 14, you add 3 to 14. And if you add 3 to 14, what you get? We get exactly 17. And then obviously we're asking the question, write down the next term of the sequence. So right, we're looking for the next term of the sequence. And clearly the next term is 17. Right, right. Next we can see n has the values. We can see a table that has been drawn for us. And this table has the numbers 1, 2, 3, 4, and 5. And we have the nth term, there, row, and we have the number 5, 8, 11, 14, and so on. And there is a next number here that was not written. So the examiner decided to omit the number there. So in 6.2, they're asking the question, determine the general rule for describing the numbers in the sequence. Right. So they want the general rule. And so what is the general rule here? Okay, let's look at this one and what we need to do here with this question. I'm giving you 2 minutes. 2 minutes. Did you bring your book? Do you have your book, your exercise book? Do you have
Yes.
your pen and your book
Yes.
and your calculator? You have.
I have everything.
Okay, thank you. I'm giving you 2 minutes because the question is saying determine the general rule. So they're looking for the general rule for describing the numbers in the sequence. I'm giving you exactly 2 minutes to actually do 6.2. And if you're done, please let me know. We're going to do it together afterwards.
Okay.
Okay.
So the general rule is +3.
Now, please come again.
The general rule is +3
Yes,
addition.
the general rule is +3. Right, the general rule is +3. Okay. I mean, you're right and you're on point by saying that. But I want to mention something else pertaining 6.2. And it's here. Right, there's a way, another way. Obviously, +3 is the rule, right? But now, in this question, we actually, therefore, for instance, in 6.3, they're asking the question, determine the sequence is 98. Using the rule, find n, the position of the term. So by the general rule in this question, we expect the following. All right, in this question, we expect the constant difference. There's something we call the constant difference. What is the constant difference? Right, so the constant difference can be obtained by saying the number 8 minus the number 5, okay? And that gives 3. But not only that, then you have the number, you need to do it twice, at least twice. or more. So you have the number 11 minus the number 8, and still you're getting the constant difference 3, 3, getting 3 here, and you're getting 3 there. Okay, so getting 3 all the way. Now, the question we then ask about the general rule is the following. So you consider the first term, consider the first. Consider the first term. What is the first term? Right, the first term is this one, and it is the number 5. So you put 5 like this. And then this first term is actually therefore equal to, right. So because we're increasing by 3, we're increasing by 3 all the way. So it means therefore a given term K is actually increased by, so the K is increased by 3 by 1. Right, so I know this is tricky, it's a tricky way to reason, but try to reason this out. So you have 5 is equal to K plus 3. Okay, then after this you transpose so the 3, which is positive, now you make it negative. So therefore the rule is, right, so the rule, what is the rule now? The rule becomes the same as, because we are adding 3 all the way, right, it becomes 3 into n. Okay, so this is how we find the rule. So to find the rule, we consider the following. So we add 3 all the way. So we add 3 all the way, right? And then we realize, therefore, that we got to the value of k. And therefore, this rule here is called the nth term. It is called the nth term. What is the nth term? Right, so we find k first if we add like this. So we find k, we say k plus 3 because we're adding 3 times 1. And then we get 2. So which means because we're adding 3, we say 3 times n because there are many 3's here. Then we add the 2, which is the value of k. This gives us the nth term. Okay.
Okay.
And that is the answer. So the general rule they wanted here, there is what? Okay, so the general rule that they actually wanted here is this one here. It's exactly this one here. Right, so what is it in essence? Right, so the general rule they wanted is basically 3n plus 2. That is actually the general rule they wanted in this question. Okay, 6.3 to follow up now. Right. So obviously you can say the general rule can be given many ways. So you can say add 3 to the preceding term, add 3 to each preceding term. So that is also one way to give the general rule, but we're looking at more advanced ways of thinking, but sophisticated ways of thinking. As you prepare to move to high school next year, there's going to be a lot of mathematics that's being done there in the senior phase at grade 8. So, right, moving towards matric, like your sister, it's very important that you begin to live on solid food. Okay, we call this solid food because primary school has the basics of mathematics, which is like a baby still on milk, because when babies are small, they only live on milk, but when they are old, then they live on solid food. So we are actually getting you ready to live on solid food. Okay, now 6.3 says the following: a term in the sequence is 98. Use the rule, or using the rule, find n the position in the sequence. Right. So in other words, using the rule, this is the rule. The rule is that 3n plus 2 is equal to the nth term. Okay, so which means we have 3n plus 2. What is the nth term? It is exactly 98. So you transpose the 2 to the other side, it becomes the 3n is equal to 98, you minus 2. And what is this? 98 minus 2 is the same as what? Is the same as 96.
6.
Okay, if you have this, then you have 3n is equal to 96. You divide by 3, you divide by 3, which means n is equal to, so if you divide 9 by 3, it becomes 3. You divide 6 by 3, you get 2. Now we continue. And therefore, the answer to this question is that because they said find the position of the term in the sequence, so the position is 32. So it means that it is term number 32 because the question was a term in the sequence is 98. So it means that you take the general term and you equate it to 98 because a term is 98 using the rule find n, the position of the term in the sequence. So the position of the term is 32. Try to think of this. Use the rule and find the term in position 50. Use the rule and find the term in position 50. So there are a couple of things I want us to note as we speak about the rules here. Okay, so now here we are speaking of a concept of the nth term. Nth term. The nth term in this question is a 3n plus 2. Another question is going to have its own nth term because each question has its own equation, its own question, its own numbers. Okay, now I want us to think of these together. But as we think of these together, we are able to think of this as follows. So what is this here? The nth term is everything. This is the nth term. What is this one? This is the position. Position of the term. Position of the term. Right. So if you look at the position of the term, what is the position of the term? Right. So the position of the term is n. The nth term is everything. So if they say to you, find the second term, the third term, the fourth term, the fifth term, they mean find everything. But if they then say find the position of the term, they want n. So in which case, therefore, n becomes a question mark. Okay. So I'm giving you 2 minutes to try 6.4. 2 minutes to try 6.4. Please let me know when you are done with 6.4. With 6.4. Okay. Okay. Let me know when you're done. Okay, so you let me know when you are done.
Is the 50th term 170?
Okay, is it 170? Okay, we're gonna check just now together and see if it is indeed 170. Let's just check if that is the case. Right, let's just check if that is the case, if it is 170. Okay, we are checking just now. We are checking just now. Right, so obviously a couple of things you need to consider here, amongst others will be what we need to do to get the answer to this. So we're looking at 6.4. So obviously we're interested in finding precisely the term they want. So this is what we do. Right, so to find the term they want, we need to know the general term. So we're interested in finding the term. How do we find the term? Right, so to find the term, we proceed as follows. So we then say it is, the general term is 3n plus 2. Is 3n plus 2. So you have 3 into, what is the n? Okay, use the rule, which is the 3n plus 2 to find, right, and find the term in position 50. Right, so the position is n, so an n is 50. What is 3 by 50? 150 plus 2, 152. Well, in other words, it means that the term in position 50, use the rule to find the term in position 50. It means that the term is, what is the term? The term is 152. The term is 152. Okay, so that
Okay.
is the answer. So here we're supposed to use the rule and find the term in position 50. So if the position is 50, it means n is 50, and you have 3 by 50 plus 2. 3 by 50 is 150, plus 2 is 152. The term is 152.
52.
Next, we're going to look at another set of questions that are involving the diagrams like this. Start with the expression 5x plus 2 equals y and answer the questions. Right, we are training you to answer specific questions by focusing on diagrams. Write down the constant and write down the constant and why it is a constant. Okay, right. First things first, we are looking at the question 7.1.1. Right. So let's answer that question. What do you think is the constant? What do you think the answer is to 7.1.1?
The constant is number 5.
Okay, that's fine. Well, Lenny, the constant here is the number that is without a variable, and therefore here the constant is 2. Right, so obviously because it's 1 mark, you just need to say, write down the constant. So this term here is called the constant. Right. Next question. Write down the variables and why they are variables. So let's look at that one. What do you think the answer is to 7.1.2?
Is it X and Y?
Thank you so much. The variables are X and Y. So X and Y are the variables. Okay, X and Y are the variables. Next question. Look at the flow diagram and answer the questions. So we're looking at 7.2.1. Right, write the flow diagram as an algebraic number sequence. Okay. So we're looking at this diagram. This kind of a diagram has a specific name. It's not just a diagram, but it is called the flow diagram. Write down the flow diagram as an algebraic number sentence. What do you think the answer is to 7.2.1? Then we look at the memorandum. It's the answers to this. That's the answer to 7.2.1. We'll discuss it together. But what do you think is the answer to 7.2.1?
Hmm.
Okay, please let me know when you're done.
I'm not so sure.
You're not so sure of this one. Okay, that's fine. We're gonna do it together. Remember that I'm trying to make sure that you exercise as we go through these questions, because my belief is that if you exercise, then you shall be fine. Right. So right. So you've never seen something like this before.
No.
All right. We are practicing everything, the whole syllabus. That's what we are doing. Write the flow diagram. So we need to write this flow diagram as an algebraic number sentence. We must write it as a number sentence. How do you write it as a number sentence? Right. So it's obvious, because in the end, what do we get? We get M. We start with K. We add 5 to it.
Mhm. Oh, yes.
So yeah. So we then continue, actually. So as we continue, we are so good. So as we continue, we are super fine and we're able to get that result there. So yeah, Right, we're getting the output, and the output is what? The output is n, and then we have many other things that are involved there. So, right. So we continue. Right. Okay.
Mhm.
Right. So this is obvious. Right. Okay. Now, so you're getting this one. So the output. So here, okay. Right. So we're getting the output. What is the output here? So the output is M, and then you start with the following. So you start with, all right, we continue. Right. So now you look at this, and you're realizing that you have M as the output. Right. So if M is the output, then you start with K. K is actually in 7.2.1. Right, because you need to write down the flow as an algebraic number sentence. An input. Right. Right. So you have an input value. K is multiplied. It's multiplied by 2. Right. It's multiplied by 2. Okay. So we have exactly that one. Okay. Okay. So we have exactly that. So yeah. Okay. We need to write down the flow diagram as an algebraic number sequence, and then write the flow diagram as a formula. So we have exactly that one there. We have exactly that one there. So now I want you to analyze that here an input value is multiplied by 2, and then 5 is added to produce an outcome value of M. Right. So in other words, M can be seen as exactly 2K plus that one. So obviously this flow diagram is understand to move like this. So in other words, you're dealing with the input and then the output. So okay, so there are many ways to write it. You can write it like that, but you can write it as follows. You just write it as follows. Right. Right. So if you cut this one here and you cut this one here, so there are a couple of things you can consider here that you actually are starting with a variable. Right. So we're using k here, but the variable sometimes is x. So if you start with x, you can start with x and then say, okay, if you have x, 5 is added to it. And then 2 is multiplied. Um, okay. Write the flow diagram as an algebraic number sequence. Right, so a couple of things you can consider here. So you have k, and 5 is added to it. 2 actually sort of multiplies the whole thing, and you get m. So you can actually convert it. Right, we can convert it as follows. And you can say the following. So an input value So the input value is k. Right, so an input value k, right, has 5 added to it. And multiplied by 2. There's 5 added to it. And multiplied by 2. Right, so we continue. Right, so multiplied by 2 to produce an outcome. To produce an outcome. An outcome value of m. Okay, we continue. Okay. So, right. So, look at the next question. What is the next question? Next question is write the flow diagram as a formula. Okay, now please try 7.2.2.
Okay.
Please try 7.2.2 and let me know when you're done. Let me know when you're done.
Okay. Mhm. Okay, so is the formula K added by 5 and multiplied by 2?
Okay, yeah. So give me the formula, please.
K added by 5 multiplied by 2 equals M.
Did you say K, right? So we write K.
Yeah.
5 is added to it and multiplied by 2. Is that what you're saying?
Yes.
Okay, let's just look at this. Right, so you are adding K 5 to K and then you multiply it by 2 and equals M like this. Right?
Mhm. Yes.
That's correct. So in other words, that's what it is. So you have written the flow diagram as a what? As a formula. So now here in 7.2.3, you must be in a position to design a flow diagram. Design a flow diagram for this. So how to design the flow diagram for this? Here you start with A. And then you multiply it by 4. Right. You take A, you multiply it by 4. Then you add 5. Then it produces B. Right. So we have this. Okay. Okay, let's look at the next question. Solve the following number sentences by inspection. So here we need to solve by inspection. What does it mean to solve by inspection? Let's solve the first one. Right, if you have to do this one, 8.1, in other words, we need to find the answers by just merely looking at these. What is the answer? X minus 13 equals 12. What's the answer?
Uh,
What do you think the answer is? It's too obvious, right?
It's 25.
Well done. It is 25 because it's 12 plus 13 and 12 plus 13. So it is 12 plus 13 and 12 plus 13 is 25. Right, if you look at 2a plus 3 equals 9, let's solve this one by inspection, by merely looking. Right, so what would you suggest as the answer?
Is it 6?
Okay, let's do it. So to do this one by inspection, it means that we must, in our heads, realize that we have the number 9 on the right. We subtract the number 3, and we divide by 2.
Oh,
What is 9 minus 3?
6,
Is 6. If you divide 6 by 2, you get what?
3.
You get 3. So 3 is the answer. Okay, so we continue with this. We continue with this. Right, so I want us to continue and do more of this. Right. Okay, let's look at these questions here. Okay, let's look at this. We have a series of multiple choice questions that are based on important things. Let's look at 1.1. The image of the trapezium is which one? Reflection of the object 180 degrees, reflection of the object 90 degrees anticlockwise, etc. C, reflection of the object 180 degrees anticlockwise, reflection of the object 90 degrees clockwise. Okay, so we are looking at this one here, and we're trying to make sense of these together. Now we are asking actually the question, what is the answer to this one here? And I'm sure you're thinking deeply, what would you suggest is the answer to these here? So I'm just giving you a sec to think obviously about this one and give and suggest an answer. What do you
Is it
think is the answer?
is it 90 degrees clockwise?
Right. So in other words, the image of the trapezium is a right. So you can see that now, obviously, now we are speaking of reflections here. Right. So obviously, if you're speaking of reflections, what does a reflection mean in essence? Okay, so a reflection obviously is different from what? It's different from a rotation. Right. So is it clockwise or is it anti-clockwise?
Clockwise?
Okay, so you're thinking it is clockwise. Right, okay, we're analyzing that together in the next minute. Right, so obviously you are on point, but a couple of things I want us to consider in terms of how a reflection is actually different from a rotation. How is a reflection different from a rotation? Right. Okay, just a sec, I'm here. Right, so we're looking at this question one, and we're getting back to these questions. So yeah, actually here as well to make sure that we are on point, and we are looking at our. This is part of what I term a control test. So right, so obviously now if you look at the reflection of the object 90 degrees clockwise, so right. So 90 degrees clockwise would be the answer to this one. So the correct answer is B, right? Because you can see that this is the object and that is the image, and therefore it would actually be just that way, transformed in that manner. When it's transformed that manner, it begins looking like the image. Okay, next question. Okay, these are like worksheets. So when you're going to write a couple of tests, and I'm going to mark those tests. But now I'm trying to exercise your mind during our discussions so that your mind is strong. Okay, so 1.2. Okay, so we continue. We continue. If you look at 1.2, if x is minus 10, x minus 10, excuse me, equals 17, the value of x equals what? Okay, so the value of x here, we're starting with x minus 10 and equals 17. So you have x minus 10, you add 10. We have 17, you add 10. So we have x equals, so what is 17 plus 10? Is
27.
7. So in other words, 1.2, the result is A, 27. The result is A, 27. Okay, next question. 1.3 now, we are testing your mind. We're training your mind. 1.3, an obtuse angle is an angle that is what? Greater than 30 degrees, but less than 60 degrees. Greater than 60 degrees, but less than 90 degrees. Greater than 90 degrees, but less than 180 degrees. Greater than 180 degrees, but less than 270 degrees. Which one is the answer? Your thoughts, please.
Greater than 90 degrees, but less than 180 degrees.
Yeah, well done. So greater than 90 degrees, but less than 180 degrees. So in other words, it is an angle of this form here. This angle is said to be an obtuse angle. So an obtuse angle means the refers to an angle that is greater than 90 degrees, but less than 180 degrees. Okay, so you have that one. Next question. Which statement is correct about a scalene triangle? 3 sides are equal, 2 sides are equal, 3 sides are not equal, 2 sides are not equal. Your thoughts, please, on a scalene triangle. What is a scalene triangle? Which option is correct about a scalene triangle, please? What kind of a triangle is scalene? What kind of a triangle is scalene?
Doesn't a scalene have no equal sides?
Definitely. So the scalene is a triangle like this. This one is like this. This one is like this. This one is like this. Or it can even have this. Well, something like that. Okay. It can even have these. But all the sides are different. So 3 sides are not equal to each other. Okay, so 1.4 is C. 3 sides not equal to each other. Okay. Right, so next we're looking at 1.5. The perpendicular lines. The perpendicular lines are lines that do what in 1.5? Are equidistant from each other, intersect at 90 degrees, intersect at any angle, bisect each other. Which one is true about perpendicular lines? Perpendicular lines are equidistant from each other, intersect at 90 degrees, intersect at any angle. Which one? 1.5. Your thoughts, please.
Perpendicular lines intersect at 90 degrees.
Yeah, definitely. So perpendicular lines intersect at 90 degrees. So the correct option is B. Here is one line and here is another. So this is actually line 1. This one is line 2. They intersect at 90 degrees. So these two lines here are said to be perpendicular lines. Why the perpendicular lines? They intersect at how many degrees? At 90 degrees. So yeah. 1.6. In the expression 5x minus 11, the variable and constant are. In the expression 5x minus 11, the variable and constant are x and 11, 5x and 11, 5x and minus 11, x and minus 11. Your thoughts, please, on this one? So here we're looking at the variable and constant.
X and
Which
11.
one is the variable and which one is the constant?
X and 11.
Okay, that is 1.6.
X
Right.
and 11. Yeah.
Right, so obviously it is x and minus 11. The variable is x and the constant is this one. So the variable is x and the constant is minus 11. Okay. In the transformation, the size of the diamond is changed by using a what? Here is the image and here is the object. You have the center of reduction or enlargement. So now in the transformation, the size of the diamond is changed by a what? Okay, by a reduction factor, by an enlargement factor, by a reflection factor, by a rotation factor. 1.7, which one do you think is the answer? 1.7.
A reduction factor.
That is 1.7. Right, so obviously here you're looking at this and this is actually the center of enlargement or reduction. So you're correct in 1.7 to say it is the reduction factor. Is the reduction factor because in the transformation, the size of the diamond is changed by a reduction factor. It's changed by a reduction factor. That's correct. It is changed by a reduction factor. 1.8, which statement is the property of a parallelogram? Let's look at A. Each angle is 90 degrees. B, all sides are equal. C, one pair of opposite angles of opposite sides are parallel. Both pairs of opposite sides are parallel and equal. 1.8, which one is the answer? which one is the answer? Okay, but obviously we're saying which statement is a property of a parallelogram? Parallelogram means you have a shape like this.
Is it both pairs of opposite sides are parallel and equal?
Okay, let's look at 1.8. Both pairs of, which one do you think? Is it A, B, C, or D?
D.
Right, it is exactly this one here. So both pairs of opposite sides are parallel and equal. So these are parallel and equal, and these are parallel and equal. Okay, let's look at, so both pairs of opposite sides, like these are opposite, they're parallel and equal. These are also opposite, they're parallel, but they're also equal to each other. Let's look at 1.9. Q shapes are congruent if they have the same shape and not the same size. They have the same shape and size. They do not have the same shape, but the same size. They do not have the same shape, nor the same size. So which one is the correct answer here about the two shapes that are congruent? Your thoughts, please. 1.9.
They have the same shape and size.
Okay, let's check that one. Definitely. So in other words, in 1.9, the correct answer is B. Well done. Right, they have the same shape and size. Let's look at 1.10. Right, in a particular year, Jane is twice as old as her daughter, Jessica. If Jane is 38 old, how old is Jessica? 1 mark, 1.10. How old do you think Jessica is? And what do you think is the answer to this question?
Is it 19?
19, huh?
19 years old?
Okay, most definitely. 1.10, it's actually correct. So it's 19 years old because in a particular year, Jane is twice as old as her daughter, Jessica. If Jane is 38 years old or 38 old, how old is Jessica? Right, so Jessica must be 19 because 2 times 19 is equal to what? It's equal to 38. And they're saying Jane is twice as old as her daughter. Next question. Right, given the expression this one, 2x minus 5, write down the coefficient of x. What do you think is the coefficient of x here?
2?
Please come again.
And the constant.
Did you forget it?
No, I mean the coefficient of x.
Okay, yeah, what did you say the answer is, please?
The coefficient of x.
Yes, please.
The
Okay.
Mm.
Right,
So
given the expression, write down the coefficient of x. The coefficient of x is this one here. Well, the coefficient of x is the number 2. Which one is the constant? Which one is the constant?
5.
The constant is minus 5. So the constant becomes minus 5. For the constant, you take it with the sign. Okay. Right. Which one is the variable here? What is the variable?
X.
Definitely. So the variable is x. The variable is x. Write the phrase certain number is added to 16 as an expression. Write the phrase as an expression. Certain number is added to 16. What do you think the result is to this? What do you think the answer is to this one? I'm giving you 2 minutes because it's 2 marks.
Is the first answer 23?
Okay, 2.2. What do you think the answer is to 2.2? Please come again.
Um
All right, are you done?
No.
Okay.
Um,
Okay.
I'm struggling a bit.
Okay, that's fine. Remember, I'm just training you with these questions. It's not that I'm interested in correct answers or anything. I'm not interested in correct answers. So write the phrase a certain number is added to 16. Certain number is added to 16. So in other words, a certain number is added to 16. That is what it is. A certain number is just added to 16. So you add x to 16. And this one is now what? An expression. Solve the following equations. Let's solve this one here. So to solve this one here, you have x is equal to 17. Then you transpose the 6. It becomes a plus. What is 17 plus 6? It is 23. You agree? Okay.
Yes.
Now, please, I'm giving you 3 minutes to solve this one. Y equals 2x. When x equals 2, you need to solve the equation. What is the answer to 2.3.2? I'm giving you 3 minutes. Hey, please let me know when you're done.
Um,
Let me know, please, when you're done.
um, I'm struggling to understand this.
I understand. Okay, it's way too easy. But always I train your mind to make sure that you become tough mentally. So you become strong mentally and you can be able to get the answers to the questions. You can be able to solve things on your own. Now, this is very, very important for us to ensure that such does indeed happen. Such does indeed happen. So, right, to solve the following equations like y equals 2x when x equals 2, so you start y equals 2x. But x is equal to 2, so you write in the place of x, you put 2. What is 2 by 2? It is exactly 4. And 4 is the answer. Okay, let's look at question 3. Question 3 says classify and measure the angle. Right, so if you need to classify and measure the angle, then you need to just classify it because, yeah, we can't
Is it
measure here now because it's on the screen. Right, but yeah, what do you think? Can you classify the angle?
an acute angle?
Well done, it is an acute angle. It is an acute angle. Next, draw a line. Draw a line AB and construct a line parallel to it. Draw a line AB and construct a line parallel to it in 3.2. So obviously that one, because it's easy just drawing, so you draw a line here like this. Call it AB. And then you construct a line parallel to it. Like this. Okay. So you have this. Right. In the equilateral, in the quadrilateral, excuse me, in the quadrilateral, calculate the marked angle X. I'm giving you 2 minutes to do the geometry 3.3, and then we shall do it together.
Calculate the
Then we shall
angle.
do it together. Too easy. Is it too easy?
I can't really calculate this because I don't have my protractor with me.
Please come again.
How am I supposed to calculate the angle?
Okay. Right. You need to calculate the marked angle X, isn't it? Which is this one here, right? You don't need to measure it. You need to calculate it. So you need to tell us what the size is, if it is 1 billion degrees, or it's 1 million degrees, or it's 1 trillion degrees, or it's just only a single degree, like 1 degree or something. We just need the answer. So yeah, it's not that we're interested in the angle, but it's already, these are just practice worksheets. So yeah, I'm yet to assess you properly, but first we need to go through the worksheets like we're doing.
Okay.
Okay. Please tell me.
Um,
Okay, so I'm giving you like 2 minutes.
okay.
Okay, I'm trying to train your mind. I'm not trying to give you like obvious things only. There are certain things that are not going to be obvious, and we are practicing together. So yeah. So, but I'm just interested in the answer. If the answer is 1 million, or it's 1 billion, or it's 1 trillion, or it's what, that kind of thing. So,
Yeah.
it's no catch. It doesn't mean that I'm trying to catch you. We're not fault hunting here. We're not looking for faults in you. We're not trying to make your life difficult, but we're trying to make your life easy. You understand?
Yeah.
Yeah.
Is the answer 62?
Okay. We're gonna look at it together because I've not done it, but we're gonna do it now. So that you can see the answer, right, in terms of what the answer is to the question. Right. Is it 62 or it's not 62? Obviously, that is what we are doing. That is what we are verifying here. All right, let's look at that one, 3.3. Right, so in 3.3 now, you need to look at the following. So you need to realize that we're going to start by the angle 65 degrees. And then we add x to it. We add 127 degrees. We add 85 degrees. 360 degrees. So it is the sum of okay, so it is the sum of the interior angles of a quad. Okay, so in mathematics, the sum of the interior angles of a quadrilateral is what? Is actually 360 degrees. So you have 360 degrees. So which means we shall have the following, right? So if you add everything here, you have x is equal to 360 degrees. You subtract 65 degrees. You subtract 127 degrees. You subtract 85 degrees. If you add everything, goodness me, yay, yay, yay. Right. So you have 127, 85, 65, and this is 83 degrees. 83 degrees. 83 degrees. So x is 83 degrees. Right. So next one, we are looking at 3.4. The triangles are similar. Answer the questions and give reasons for your answers. Right, so I can give a small exercise here in 3.3. Here is an exercise for 3.3. You have a triangle like this, and then we put into the triangle a couple of stuff like these, which is um x plus, let me just remove this one. Righty, okay. Let's take this one, doesn't matter. Or perhaps this one, okay. Right, so if you have this one here is x plus 5 degrees. This one is 5 degrees. And this one is 10 degrees. Find x. What do you think the answer is? Find x. Find x. All right. I'm giving you 2 minutes to do that one, 3.3.
Mm,
Okay. Let me know when you're done, please.
mm.
Okay, you're done.
No,
Okay.
it's kind of tricky. Me.
It's kind of
All
tricky,
right.
right?
Yeah.
Right. So obviously to get the answer here, what you need to look at is that you need to add all of them up. So you need to add 5 degrees, x plus 5 degrees equals 180 degrees. Okay, because if you add the angles in a triangle, you get what? 180 degrees. So this is a sum of interior angles of triangles. So which means that we have x is equal to 180 degrees. You subtract 10, but 5 plus 5 is also 10. So which means x minus 20, which is 160 degrees. So x is 160 degrees.
Okay.
Right, let's look at 3.4. Right, the triangles are similar. Answer the questions and give reasons for your answer. Calculate the size of angle C. What do you think angle C is at this point?
Let's
What
see.
do you think angle C is at this point?
Is it 33 degrees?
Please come again.
33 degrees.
Yeah, that's correct. The angle C is 33 degrees. Since angle F is 33 degrees, right, this is true since angle F is 33 degrees and the triangles are similar. The triangles are similar. Right, so I want you now to find the angle A. What do you think angle A is?
Is it the same as 33 degrees?
Please come again.
The same as 33 degrees?
Um, Not really. Find angle D. What do you think angle D is? This one here? Calculate angle D first, and then we shall do the corrections. Right, first find angle D. Tell me what you think angle D is in the shape.
Um, the
Let me know when you're done.
I'm not so sure.
Okay, that's fine. We're practicing here. We're training you. What did you say the sum of the angles is here? What did we do here? We added all of them up and we got 180. So here we need to add this one plus this one plus this one. We need to get what? 180 degrees. So to get the size of the angle D, what we require is that we add all these up. So we're going to add 33 degrees This one plus 90 plus angle D, which is 180 degrees. 180 minus 90 minus 33 degrees. What is 180 minus 90? Is 90. 90 minus 33, 90 minus 30 is
57.
60 minus that 57 degrees. Yes. So in other words, angle D is 57 degrees. Exactly 57 degrees. Any question?
No.
All right, so next question. Right, now calculate the length of EF. Let's find the length of EF. What is the length of EF? Want to find the length of EF? I'm giving you 2 minutes to calculate the length of EF, okay? Here is E and here is F. So what is the length of EF? If this one is E here, and F is this one, what is the length of EF? 2 minutes. Let me know when you're done.
Is it 11 centimeters?
All right, now look at what happened. So in other words, 7 was changed into 21. So 7 becomes 3 times 7. So if it's 7, then multiply by 3. If it's 10, you multiply by what? By 3. Because 7 was multiplied by 3. 7 times 3. What is 7 times 3? It's 21. So even 10 times 3 is what? 10 times 3 becomes 30. So the length of EF equals 30 centimeters. Equals 30 what? Centimeters. Okay, so next question. Right. Okay, let's look at figure 4 now, and we're looking at the question 4.1.1. Right, let's see. Okay, here's the question. Describe how the rhombus A has been translated to obtain rhombus B. How was rhombus A translated to obtain rhombus what? Rhombus B. How? Here is rhombus A and rhombus B. What do you think happened? Right, I'm giving you 2 minutes. And then we're going to discuss the answer.
Was it rotated?
Okay, was it rotated? Let's just look at that and see if really that is the case, if it was most certainly rotated or not. if it was rotated or not. Right, let's take a look and see what transformation actually happened that to result this actually. And let's think about these most certainly together and see what we can observe out of this here. And observe something together. Okay, was it rotated? Let us see. But obviously you can see that it was not rotated. Right, so I want us to think more about what actually happened, but it was not a rotation, it was some other form of transformation. Right, so look at it carefully and think about the transformation that led to that.
Mm,
So one more minute. One more minute.
um,
Okay,
um,
think about it very carefully and let me know what you think. We are not rushing, we are not running here, we're not in a marathon, but we are learning. But now I'm interested in seeing what you think of this, you know? So I'm interested in knowing what your thought is on this so that we can most certainly be very sure of a right, obviously I've enlarged the shape so that you're able to see clearly the forms of transformation that are being discussed here. Right, so I'm sure that you're able to see that there are a couple of transformations that have been performed. And now these are basically translations. So the shape has basically been translated. It's been translated by a couple of units. Let's see together. Okay, I always give you a chance to think about it. So in other words, the rhombus was translated by 20 units, 28 units to the right. So because if you look very carefully, you realize that it was moved here one, two, okay, it was moved. So yeah, let's take this one here. So this one here now, okay, you here. So it was here, then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. So look at that very carefully and think. So we are looking at by how much was it displaced? Right. So obviously if you count one from here, so you remove this one. Okay, you cut this one. So you look at one. So I'm gonna do that like that. Two here, three here, four here, five, six, seven, eight, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so we're getting like 28 possible movements. So, right, I would have done it horizontally like this, but I did not want to because these numbers would like be very close to each other. So now we are having this one. So what do we say about this? So it's 28 units right. "28 units right." And then you're gonna look at how many units down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we counted 15 here. So that is 28 units right, and then 15 units downwards. Okay, so you have 28 units right and then 15 units downwards. So that is sort of the transformation. Okay, I tried to increase reflect rhombus A in the line AB and label its image A primed. Reflected reflect rhombus A in the line AB and call its image A primed. Okay, if you reflect the line AB and call its image A primed, what is it going to be?
Uh,
How is it going to be like? So obviously you need to look at how many. Well, that's 1, 2,
2,
3 here. So
3.
that's 1, 2. Yeah, count 1, 2, 3, 4. 1, 2, 3, 4. We're gonna have this one here. Right. So this one is goes down like this. So it's gonna be something like that. So this is rhombus A primed. Rhombus A primed. Right. So this is the sort of shape you're getting. Okay, so now if you look at this shape here, 4.2, a student must be able to draw this shape, but also be in a position to draw all the lines of symmetry. Okay, if you draw the shape and draw all lines of symmetry, how many lines of symmetry do you think this square has?
2 lines.
How many?
2.
2 lines of symmetry. Okay, we're asking the question, how many lines of symmetry? Right, so the lines of symmetry, it has a lot of them, like there is a line of symmetry here. That is number 1. There's another one here, number 2. Because if you cut it in the middle like this, if you slice it like a loaf of bread and you slice it like this, so this piece is going to be the same as that piece. It's going to be identical to that piece. But also, if you cut it horizontal like this, the top piece is going to be identical to the bottom piece. Right, so you have this one here. And also this one here. Um, So that is 2, and then you have 3, and then you have 4. If you slice it like this, it's going to have this right angle part. It's going to have this pointed part. So in other words, this one has exactly how many lines of symmetry? It has exactly 4 lines of symmetry. 4 lines of symmetry. Right, so we have these. Then we continue. Okay, if you look at 4.3, redraw and enlarge the line AB by a factor of 2. Right,
Okay.
use A as your center of enlargement. Okay, so if you look at this enlargement thing, so if you use A as your center of enlargement, you have 1, 2, 3, 4, 5. Okay, that is 6, 7, 8, 9. So 1, 2, 3, 4, 5. 6, 7, 8, 9. Looks like 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's count here. So you're gonna count 1, 2, 3, 4. Okay. And then you're gonna count 1, 2, 3, 4. So you're gonna stop there because you want this to have the same size as that one. So we have this. Right, so you have that. So read and enlarge this one. Right, and enlarge the line by a factor of 2. Use A as a set of enlargement, so it's going to be exactly like this. So in other words, this is going to be like a B there. It's going to be like a B there. So yeah, that's what you get. It's going to be like a B. Right, so it's going to be up to there. Up to exactly here. Right. So that's what you have. Next. We continue. Let's look at this other one. Okay, let's look at this shape here. Study triangle ABC and triangle CED and answer the questions. So we are looking at these two shapes and need to answer the questions. What type of triangles are triangle ABC and triangle CDE? Triangle ABC and triangle CDE? What
Are
kind of
they
triangles are these?
congruent giant triangles?
Right, let's take a look and think very carefully. So first things first, we are looking at this one. It is part of my exercises. So we are looking at media test 2, right? Because I have lots of so it's part of my worksheet. This one, but I've classified it as a media test. So, but there's certain things you're supposed to be able to do by mid-year, by the middle of the year, like these questions. Okay, so let's look at 2.1. What type of triangles are triangles ABC, and what do you think again is the answer?
Uh,
You gave me the answer, right?
um,
But I need to be sure that I heard you well.
and is it an isosceles triangle?
Yes, isosceles. Well done. Congratulations. Isosceles triangles. Right. So they are isosceles. All right. The isosceles because isosceles means you have two sides equal. So here you have this sides equal, and so you have this triangle here has two sides equal, two sides equal. Determine the value of the angle B. What is the size of the angle B in your view? 2 marks, 2 minutes. 3 marks, 2 minutes.
Um, value. Um,
What do you think? Okay, so in other words, because this side equals this, it means that this angle equals this, and therefore this angle is 40 degrees. So what is the determine the value of the angle B? So in other words, it follows that the angle B is actually 40 degrees. Are triangles ABC and EDC congruent? Triangle ABC and EDC congruent?
Mm.
1 mark.
Yes, they are congruent.
Why do you think? Okay, okay, that's fine. So obviously this pointer is just 1 mark. So yeah, you don't need to reason a lot. So the answer is yes, they are congruent. Um, if they are, state your reason. So obviously, yeah, we need the reason. So you have two sides of triangle ABC equal to two sides of triangle, and both the triangles so have an equal corresponding included angle C. We call these the SAS rule. So here is the reason. The reason is that two sides of triangles of triangle ABC two sides of triangle ABC are equal to two sides of triangle EBC, and both triangles have an equal corresponding have an equal corresponding included angle C. We call these the SAS rule. We call this the SAS rule. So in other words, you have side, angle, side, you have side, side, you have side, angle, side. So this is called the SAS rule. Okay, because you have the side, angle, side rule. Okay. Next question. So now we're looking at more geometry, and now in our next lesson, we shall go deep into geometry, because geometry is what forms part of this term. So this term is full of geometry, so you must understand a lot of the geometry. Study the quadrilateral and answer the questions. Name the quadrilateral in the illustration. So there's a quadrilateral here that you need to study very carefully and answer the questions, okay? So name the quadrilateral in the illustration. What do you think is the quadrilateral in the illustration? Your thoughts, please.
I don't think there is an equilateral. I mean,
all right, that's fine because we're practicing. Okay, this quadrilateral normally that is like this has this side here equal to this one. It has this equal to this, and there's a special name. It's just called a kite. It's called what? A kite. Okay, because sometimes this kite is, there's a tail here like this. You can put a little tail. Then put a string and then it flies in the air, right? So it's a kite. Okay, so complete the statement. Diagonal CD bisects diagonal AB at what angles? So diagonal CD bisects bisects diagonal bisects, excuse me. So diagonal CD bisects diagonal AB at what angles?
90 degrees angle.
No, it is exactly at 90 degrees, because if you have a kite, they bisect each other at exactly 90 degrees. Determine the length of BD. Determine the length of BD. What is the length of BD here? So we can see that clearly BD is what? What do you think the length of BD is here? I'm giving you 1 minute. One mark. Mm-hmm.
How do I determine the length of BD?
Please come again.
How do I determine the length of BD?
Yes, because they want you to find the length of BD. Okay, I know that is too easy, but always I test you because I want to make sure that you're tough, you're strong, and you can be able to answer questions in the exam. And that is the whole thing. I don't normally give lots of projects myself. I'm happy if you can answer the questions in my class, and then I'm just convinced that you're okay.
So it's 5 centimeters.
It is exactly 5 centimeters. Well done. It is 5 centimeters. Why? Because we've already said it is equal to it is equal to AD. AD is 5, so BD is also supposed to be 5 centimeters, okay? Let's look at this shape here. Start the illustration and answer the questions. Are these two shapes similar or congruent?
They are congruent. I mean, similar.
Okay, so the two shapes here, similar shapes are shapes that have
The same
shapes
shape.
are shaped, well, congruent shapes means they are identical in size.
Mm-hmm.
And shape or form. So this one, surely one is bigger than the other. So they are similar shapes. They are similar shapes. But we can see that they are equiangular because this angle is 90 degrees and everything else is like, but just that this one is bigger than that. So they're similar. If they're congruent, then they must be like the same size. Okay, so they are similar shapes. Right, so if you look at 2.3.2, what is the ratio of the corresponding sides BC to BC? BC to BC. What do you think the ratio is? 2 marks.
Ratio of 2 and 6.
Yes, so the ratio, they're looking for the ratio here. So the ratio is 2:6. Okay, if you look at 2.3.3, write down the value of D.
Is it 2 centimeters?
Please come again.
2 centimeters.
Right, so let's see now here. Just 1 second. Right, so yeah, I'm having Ligugu is my other student. So hello Gugu. Hello Ligugu. Okay, what do you think the value of D is there, Lindsay?
Angle D, is it 2 centimeters?
Please come again.
2 centimeters.
Right, so angle D is actually exactly this angle here. So we can see that the angle D, angle D is actually equal to 90 degrees.
Oh, that they wanted the measurement.
So angle D is equal to 90 degrees. Right, so angle D is equal to 90 degrees. Right, so angle D is equal to 90 degrees. Okay. Pick something else. Right, so if angle D is 90 degrees. Okay. Let's look at question 3. Study the figure and answer the questions. Name the figure shown in the diagram. What do you think the figure is in the diagram? Name it. What do you think the name is of that shape?
Rectangle.
Most definitely. So the shape here is a rectangle. Convert 30 millimeters to centimeters. What do you think the answer is going to be?
3 centimeters.
It's going to be exactly 3. So because you take the 30 and you divide it by 10 to convert it from millimeters to centimeters, and therefore it becomes 3 centimeters. Calculate the perimeter of the shape. What do you think the perimeter of the shape is? Perimeter?
30 centimeters.
Please come again.
30 centimeters.
Okay, let's see. Right, so the perimeter is always twice into the sum of the sides. So you have twice into 12 plus 30. Twice into 42. Twice into 84. Calculate the area of the figure. Write the area. So the area of a rectangle is always length by what? Length by breadth,
Base.
right?
Yeah,
So
breadth.
yeah, this one is the length and this one is the what? Is the breadth. So the length is 12. The breadth is 30. Obviously we said it's 3. So you have 3. Oops. Okay. Right. Obviously, I want you to note the perimeter here because you need to change here because this one is in terms of the is 3 only. So in other words, it's 12 plus 3.
15.
So 12 plus 3 is 15. What is 2 times 15?
30.
Yeah, so it's going to be 30 because of that. Right, so obviously here the area is 12 by 3. What is 12 by 3?
24.
36.
Oh, 36.
That's fine. So it's 36 square centimeters. Okay, right. This is going to be enough for today. Right. Another student was already joining me, so I'm gonna see them at 4:30. But thanks a lot. In the next couple of minutes, I'm gonna load the video so that you can watch. So when you watch the video, the couple of things that remain important is for you to take down the notes. Okay.
Okay.
Okay. Thanks. I'll see you next Saturday. Okay.
All right.
Next Saturday around 2 p.m. is what time suits you on Saturdays?
Yeah, 2 p.m. is fine.
2 p.m. is
2 p.m.
okay. Right. So yeah,
Yeah.
think of that. Saturday, 2 p.m. if that is okay with you. Yeah, thanks and goodbye. I'll send a video in a couple of minutes. Okay.
Okay.
Thank you and goodbye.
Bye bye, sir.
Mhm.